I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. A groundbreaking technology designed by Ireland-based researchers is poised to essentially redefine interactions between the digital and physical worlds. A team from Vivid Photonics, a spin-off of Tyndall National Institute and the Research Ireland Centre for Photonics, has developed a horizontal cavity surface-emitting superluminescent diode to significantly boost image quality for augmented and virtual reality applications. The gallium nitride-based technology includes a horizontal cavity with a 45-degree total internal reflector that redirects light outward for improved emission, and a ridge waveguide architecture that confines and guides light more efficiently. The device's superluminescent diode component produces broadband light emission with high coherence. The team says the setup is ideal for applications requiring a light source with a broad spectral output, but not the spatial coherence of a laser, projection in holographic displays, and holographic and imaging systems, for example. While improvements to the technology's performance and scalability are ongoing, the team is also working to expand it into the entire RGB spectrum, with the goal of seamless integration into real-world AR/VR devices and other similar systems. A new project supported by the Photonics Partnership for Photonics Technology Advancement is getting a boost in the form of a €6 million investment. The investment by the European Commission will aid the Sprinter project, a European research and development initiative that aims to create an ultra-fast, energy-efficient industrial internet that will use lasers and next-generation flexible and adaptable wireless to power future smart factories. Program officials say their developments could potentially replace existing networks with faster laser-driven communication systems made specifically for industrial settings. In other investment news, Astrape Networks, a Netherlands-based deep tech startup, has secured €7.9 million from investors including Photon Ventures. The funding, which includes a €2.5 million grant from the European Innovation Council, will allow Astrape to scale its energy-efficient, AI-optimized data center networking solutions. The work aims to solve so-called traffic jams common with existing modern data centers, which company representatives call an urgent bottleneck in the AI revolution. A demonstration of tornado-like structures has helped an international collaborative of scientists achieve a milestone in the quantum materials realm. The team, led by researchers at the University of Würzburg and the University of Dresden, has experimentally shown that electrons can form orbital vortex lines, essentially cyclone-like structures, within momentum space of quantum semi-metal tantalum arsenide. Quantum materials' electronic structure is expressed within that space. Topology as a basic quantum concept is fundamental to the team's work. A so-called quantum tornado is a topological object featuring a defined quantum number that twists around the core. In their approach, the team brought together angle-resolved photoemission spectroscopy with linear and circular dichroism, in which light absorption changes based on different directions of polarization. With this combination, they could reconstruct orbital vortices. Individual images could then be stitched together to create a 3D structure of the orbital angular momentum, in turn confirming the original findings of electrons forming vortices within momentum space. The team is now exploring ways to apply their approach to other classes of quantum materials, like chiral materials and altermagnets. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.